Okay, now we continue our topic queue, part 2, where we look into another concept of queue is circular queue. Previously, when we learned about queue, we have a list of items. We have a front and rear. But in this example, they use another term first as a front of the queue, the term last for the rear of the queue. So first and last. You can see here that there's 7 items in the queue. And then when you enqueue another item into the array, that means the last will be increased by 1. When you dequeue, you remove from the front and the first value will increase by 1. So that means you can see that there's a space in front of the queue that is not used. The bad thing is that as items are dequeued, front of the array are never reused and the space become wasted, because every time you enqueue at the back and then the array will become bigger. This is not a good way to implement a queue. So what the solution? And we apply circular queue. Means that the last element will be followed by the first element. In this example here, we have array of size 5, but we draw like a circle to look into how we going to apply queue in a circular. So there's the same variable front and rear, we initialize to -1 because the queue is empty and the count equal to 0. So let's see the process of circular queue. Okay, first queue is empty, front and rear -1. When you enqueue 10, both front and rear will increase by 1 for the first time, because that will be the first data in the queue. Then when you enqueue another item, let's say you enqueue 20, only rear is increased by 1. Front will still maintain the position, the front of the queue, but rear will increase by 1. So remember, front and rear is only hold the index value. So when you enqueue 30, 40, 50, 60, 70, 80, then it will fill up the whole list, the whole queue, and you can see that every time the process enqueue, rear will be increased by 1. So now front is 0, rear is 7. Can you enqueue another item, enqueue 90? No, it will be overflow. The statement will be queue is already full. So front and rear still maintain the index value 0 and 7. So now, can you dequeue? Yes, you can dequeue because there's element or item in the array in the queue. So when you dequeue from the front, so front will increase by 1. Rear maintain as the end of the list. So front will be 1, and then when you dequeue 3 times, then front will be increased by 1 for 3 times. So now front at 4, rear at 7. Now, can you enqueue 90? Yes, because there's a space here that we can use. So now rear is in 7 position. Now if you want to enqueue, you can move the rear into the 0 position. So 90, enqueue 90, but the rear will be 0, front maintain 4. And then when you enqueue 100 and 110, rear is increased by 1, so rear now at 2, front maintain at 4. Okay, now when you dequeue, you dequeue from front. So 1, 2, 3, 4, 5, 6 dequeue. So 1, 2, 3, 4, 5, 6 dequeue, and the last element will be here 2. So front will be increased by 1 each time the dequeue process is executed, and then now the front and rear is at the index 2. Now when you dequeue the last item in the array, you must initialize back the front and rear equal to -1, because there is no item left in the queue. And then when you want to dequeue with the empty list, it will stated that the queue is empty. That means underflow. So this is all the basic process of NQ and DQ, and how front and rear move the position so that you can use the space, optimize the space that in the array. Now, how are you going to know the front and rear position if you don't have the diagram? You can just use the formula. Let's say you want to NQ 30. Now you can say that rear plus 1 mode size. So NQ 30, 70 and 40. So you NQ 30, 70 and 40. Now we rear as 2, front and 0. So for the first NQ 30 means that front and rear move the position 0. So how are you going to know the rear of the array? That means, first of all, negative 1 plus 1 equal to 0. 0 mod size is 5. So 0 mod 5 equal to 0. That means rear at the 0 location when you first NQ 30. When you want to NQ 70, what is the rear position now? That means rear is at 0. So 0 plus 1 mod size 5. So then 0 plus 1 is 1. 1 mod size 5 equals to 1. So rear will, the value will be increased by 1. When you NQ 40, now it's rear at 1. So 1 plus 1 equals to 2. 2 mod 5 equals to 2. That's why rear equals to 2 here. So that will be the formula when you want to know the rear value. How about want to know the front value when you DQ from the list? So when you want DQ, the first DQ from the list, front equal to 0. 0 plus 1 mod 5. That means front will be point at 1. So front equals to 1. So when you DQ again, 1 present in this formula, 1 plus 1 equals to 2. 2 mod 5 equals to 2. That means front equals to 2. So you can use the formula to know the position of front and rear. Here for another process NQ. So 50, 80, 100. So 50, 80, 100. So this is the thing that you want to optimize the space available in the queue. So the last will be rear is at 4. It means 4 plus 1 is 5. 5 mod 5 equals to 0. It means rear move to 0. That will be the last item NQ'd into the list. Thank you.